Okay, this is a last subtopic for the chapter 1, logic gate and simple logic circuit. So in this chapter, we will write logical operator and its expressions, symbols and truth table. And also we will identify the combinations of different gates such as not AND, not OR, exclusive OR, and exclusive NOR. And also we will write the Boolean expressions. We draw the truth tables and we draw the logic diagram. So Boolean expressions. What is the Boolean expressions? Boolean expressions is an expressions that involve value, variables, and operations. Value, variables, and expressions. Variables can be represented by letters and it can have one or more values, either 1 or 0. It also carry out with a logical operator. Logical operator are typically used with Boolean values true or false. Two or more Boolean expressions can be combined using Boolean operator. There are three basic logical operator. The first one is logical operator AND, logical operator OR, and logical operator NOT. These three basic operators can be combined with variable to form Boolean expressions. The example of Boolean expressions is A plus B dot C. This is called AND operator. This operator is a logical multiplications of A and B as a variable. Is written as A dot B. Or read as A and B. The Boolean equations for AND operators can be written as Y equal A dot B, or we can write as A B, or we can write as Y A intersection B. The symbol for this gate is like this. A B as an input and the gates is like this, and Y as an output. The truth table show it is true. This is a true if and only if both of A and B are true. Now we're going to the next operator is called OR operator. This is the logical additions of A and B is written as A plus B. The Boolean equations for all operations can be written as y equal A plus B or y equal A union B. Symbol for OR gate is like this. A, B as an input, go through the gate, the OR gate, and Y is an output. Truth table shows it is true, 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 and true outputs if either A or B, A or B, or both are true. So the next operator is a NOT operator. The NOT operator or NOT gate will produce inverted versions of inputs of its outputs. The NOT operator is written as A bar and read as NOT A. The Boolean expression for the NOT operator is y equal to bar A or y equal not A. And the gate for the NOT operator is like this. A as an input, Y as an output. And the truth table shows if A is a true, the output will be false. And if A or input is a false, the output will be true. Okay, now we're going to the not and gate. Not and gate. Not and gate, or we can pronounce as a non-gate. It's a combination of and not gate. Assume that A and B are the inputs and Y is an output, the symbol for the NAND gate is like this. From the truth table, it shows the gate will produce true, the output true, the output true when any of the inputs are false. True, true, and true when any of the inputs are false. In this case, so the first row, the both input are false. The second row, input A is false and the output is true. And the third row, the input B is false and the output is also true. Okay, next is the NO gate. NO gate is the combinations of OR gates and NOT gate. As usual, assume A and B are inputs and Y is an output. The symbol for AND OR gate is like this. From the truth table, the gate will produce true, so the output produce true. The output will be produced true when all of the inputs are false. And the output produce false, 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 and false when any of the inputs are true. In second row, we found that the input B is true, so the output should be false. And the third row, the input A is a true and the output should be false. And the last row, the input is both are true and the output is false. So the next gate is a XOR. We can pronounce it as a exclusive OR gate. This gate is a logic gate with two or more inputs and one output that performs exclusive disjunctions. Symbol of XOR gate is like this. So the input is A and B, and the output is Y. From the truth table, it shows the output is a true. The output is a true if one of the inputs is true. In this row number 2, the input A is a false and input B is a true. So the output will be true, as well as row number 3. If an XOR gate, this gate has more than 2 inputs, 3, 4, or maybe 6, then the output become a true if there is a odd numbers of its inputs is true. Okay, now is a XNo gate. Is can we can pronounce as a exclusive and or. The gate is the reverse or inverted to the XOR gate. It is combinations of AND gates, OR gates, and NOT gate. An XNOR gate is a logic gate with 2 or more inputs and 1 outputs that perform logical equality. The symbol of XNOR gate is like this. A and B as an input and Y as an output. The truth table shows the output of an XNOR gate is a true, and true. The first row and the last row true. When all of its inputs are true, the last row we shows that the input both A and B are true. And the first row, it shows that input A and B are false. So both produce true output. If some of its input are true and others are false, then the output of the exclusive NOR gates is false, like row 2, and row number 3. Before we proceed to the next topic, you need to answer some questions below. You are given about 10 minutes to answer. You can make a discussions among your friends. You can start now.